अभी हम प्रॉब्लम सेट 6 जो है वो सॉल्व करने वाले हैं. उसमें का क्वेश्चन 5 प्रूव द फॉलोइंग आइडेंटिटीज वो करेंगे पहले. सो उसका ये एग्जांपल है सेक थीटा इंटू 1 माइनस साइन थीटा इंटू सेक थीटा प्लस टैन थीटा इज इक्वल टू 1. सो कंसिडर LHS sec theta into bracket 1 minus sin theta into sec theta plus tan theta. Okay. Now, for sec theta, substitute 1 upon cos theta. We know sec theta is reciprocal of cos theta. Then write this bracket as it is for now. And here sec theta is again 1 upon cos theta and plus tan theta means sin theta upon cos theta. Now in this bracket we have same denominator and therefore we can write this as 1 upon cos theta into 1 minus sin theta, and here 1 plus sin theta and common denominator is cos theta. Now what happens, in the numerator we have 1 minus sin theta into 1 plus sin theta, and in the denominator cos theta, this cos theta and this cos theta becomes cos square theta. Now see, in the numerator we have terms like this, a minus b, a plus b. And we know this identity that becomes a square minus b square. So we can write the numerator as 1 square minus sin square theta upon cos square theta. And using the first identity is sin square theta plus cos square theta is equal to 1. Shift this sin square theta, so we get cos square theta is equal to 1 minus sin square theta. So for this 1 minus sin square theta, we can write cos square theta upon cos square theta and cancel this, which is equal to 1, and that is our RHS. So we have proved this identity. Okay, second example, prove the following. Consider LHS, that is sec theta plus tan theta into 1 minus sin theta, and we have to prove is equal to cos theta. Like in the previous example, substitute 1 upon cos theta for sec theta and sin theta upon cos theta for tan theta into 1 minus sin theta. Okay. Now in first bracket we have same denominator, so write it as common denominator, and in the numerator we get 1 plus sin theta and into 1 minus sin theta. Again here we have two brackets in this form, a plus b, a minus b, which is equal to a square minus b square, and therefore 1 plus sin theta into 1 minus sin theta is 1 minus sin square theta upon cos theta. Now we know the identity, sin square theta plus cos square theta is equal to 1, and hence cos square theta is equal to 1 minus sin square theta. So in the numerator write cos square theta. Value of 1 minus sin square theta is cos square theta upon cos theta. Now cos square theta means cos theta into cos theta upon this cos theta, and hence we can cancel one cos theta and the remaining thing is cos theta, which is our RHS. Hence we have proved this identity also. Next example is sec square theta plus cosec square theta is equal to sec square theta into cosec square theta. Okay, so consider LHS again, that is sec square theta plus cosec square theta. ये सब एग्जाम्पल्स बहुत ही ईजी है, सो आप एक दो बार करोगे तो याद रह जाएगा. सो सेक स्क्वायर थीटा मीन्स 1 अपॉन कॉस स्क्वायर थीटा. हमें पता है सेक थीटा इज रेसिप्रोकल ऑफ कॉस थीटा, सो सेक स्क्वायर थीटा इज रेसिप्रोकल ऑफ कॉस स्क्वायर थीटा. and cosec square theta is reciprocal of sine square theta. Okay, now here cross multiply, that means we get 1 into sine square theta plus 1 into cos square theta and upon cos square theta into sine square theta. Okay, and we know numerator, in the numerator we have our first identity, that is sine square theta plus cos square theta is equal to 1 upon this cos square theta into sine square theta. Now here 1, write this as 1 upon cos square theta into 1 upon sine square theta, because 1 into 1 is 1, we can separate like this, and 1 upon cos square theta is sec square theta into 1 upon sine square theta is cosec square theta, and this is our RHS. Okay, and hence we have proved this identity. This is the next example. Again in this consider LHS, that is cot square theta minus tan square theta is equal to, we have to prove cosec square theta minus sec square theta. Now we know the identities in cot square theta and tan square theta, so 1 plus cot square theta is equal to cosec square theta. So cot square theta is equal to cosec square theta minus 1. That means for this cot square theta we can substitute cosec square theta minus 1, because on the right side we require cosec square theta. Okay, get the logic behind this. And 1 plus tan square theta is equal to sec square theta, and hence tan square theta is equal to sec square theta minus 1. Now here we have minus sign in between, so this minus, and then write the value of tan square theta in the bracket, sec square theta minus 1, and now just simplify. So cosec square theta minus 1 minus sec square theta, and this minus becomes plus 1. And now we can cancel this minus 1 plus 1. So that is equal to cosec square theta minus sec square theta, and this is the RHS. Hence proved. Okay, next example. Consider LHS tan raised to 4 theta plus tan square theta. Now here we can write this tan raised to 4 theta as tan square theta bracket square plus tan square theta, and therefore we can take tan square theta common from both the terms, and remaining terms in the bracket as tan square theta plus 1. Now we know the identity, tan square theta is 1 plus tan square theta is equal to sec square theta. So for this bracket we can write sec square theta, and tan square theta is equal to sec square theta minus 1. So for this tan square theta we can write sec square theta minus 1. So here sec square theta minus 1 into sec square theta, and just simplify sec square theta into sec square theta as sec raised to 4 theta minus 1 into sec square theta, that is sec square theta, which is our RHS, and hence it is proved.